Alright, let's get started. In step 5, we'll create the database context, the bridge between our C# models and the SQL Server database. This context allows our application to talk directly to the database using Entity Framework Core. First, create a new folder called Data. Inside that folder, add a new file named application_db_context.cs. We define a class called application_db_context. This acts as our bridge between code and the actual database. The constructor calls the base db_context, passing configuration options that tell Entity Framework how to connect. And finally, db_setOfProduct creates a table called products in the SQL Server database based on the product model. Great, now let's make sure the application knows about this context. Open program.cs and register it with dependency injection by adding this line. This single line is powerful. It tells our app to use the application DB context whenever something asks for a database connection. It also configures it to use SQL Server with the connection string stored inside appsettings.json. That way, every controller or repository that needs access to the database automatically gets a properly configured instance. Now, let's create the actual database tables. Go to the Package Manager console and run these two commands, one at a time. Add migration initial, create update database. Here's what's happening. Add migration. Initial create captures the structure of your models and generates migration scripts. It's like taking a snapshot of your code models. Then, update database applies those scripts to the SQL Server database, automatically creating all necessary tables and relationships. And that's it. You've just connected your C# project to SQL Server through Entity Framework Core using a clean, well-structured application DB context. Nice work. This foundation will make data operations in your app smooth and efficient. Great job so far! Now that our database context is ready, let's test the application by creating a controller. The controller is what handles incoming requests and connects them to our database logic through the Entity Framework Core. First, open the Controllers folder, right-click it, then choose Add, and select New Controller. On the left side of the dialog, select API. We're creating an API controller, so make sure to pick the option that says API Controller with Actions, using Entity Framework. This template will automatically create the basic methods, like get, post, put, and delete, so you don't have to write them from scratch. Once selected, click Add. Now you'll see a configuration window. In the Model Class dropdown, choose Product. This tells the controller which data model it will handle. Next, look at the Data Context field. It should automatically select Application DB Context, the one we created earlier. If not, select it manually. We'll name this one ProductsController.cs. Notice it's in plural form. It helps Entity Framework and other parts of the app stay consistent with naming conventions. When everything looks good, click Add. Visual Studio will generate your controller file for you. Inside, you'll find ready-made methods that can read data, create new products, update existing ones, or delete them, all connected directly to your SQL Server through the application DB context. That's it. You now have a fully functional API controller. In the next step, we'll explore how to test it and confirm that everything works correctly. Alright, now it's time to see our work in action. Let's start the application by clicking on the green play button at the top. This will launch the project and open our product API in the browser. Once it loads, you'll see the list of endpoints: get, post, put, and delete. These are the methods we use to interact with our products in the database. Let's test each one so you can see how they work. First, let's add a new record to the database. Click on Post, then select API/products. In the request body, type in a sample product. For example, the name can be Apple. In the description field, you can simply write fresh red apple. Set the quantity to 100 and the price to 5. Once everything is filled in, click Execute. Entity Framework Core will send that data to SQL Server and create a new product entry. Now let's make sure it was saved correctly. Click on Get, then select API/products. Click Try Out, and then press Execute. You should now see a list of products, and your new item Apple should appear there with all the details we entered. Pretty cool, right? But here's something important to think about. If you add more controllers for different models, you'll start to notice the code becoming repetitive. Each controller will have very similar logic, fetching data, updating, deleting, and so on. And while copy and paste might seem fast today, it usually becomes a problem tomorrow. It's harder to maintain, and small changes can turn into big headaches. The solution is to create a generic repository. With a generic repository, you centralize your database operations in one place. That means if you ever need to change how something works, you update it once, and the whole application benefits automatically. That's what we call clean architecture: efficient, maintainable, and scalable. In the next videos, we'll take this idea further. We'll create helpers, repositories, and implementations to make our project cleaner and more powerful. So stay tuned, we're just getting started.